Okay, in this lesson we're going to look at graphical misrepresentations of data, otherwise known as lying with statistics. So here's a graph here. These are called pictograms. You'll see a lot of these in the newspapers like USA Today and such. Very rarely would you see something like this in a professional journal. And many might think this is a pretty good way to show Titanic data, is with this sort of display. We got the crew, and we may look here, it looks like, and they didn't really label what this was. I imagine this is deaths or something. And then the third, and then second, and first. So it looks like the crew really outnumbers everybody else. But what is wrong with this sort of display? It looks like they were almost all the crew members, with just a few other passengers sort of along with the ride. But if you look at each ship, we see that the area is taken up by the ship instead of the length of the ship, which is misleading. So the ship violates what's called the area principle. And it simply states that the area occupied by a part of the graph should correspond to the magnitude of that value. So a bar chart is really a better way to represent this. It stays true to the area principle, and so this is what that other display looked like. So go back and compare on your notes what those look like, and you can definitely tell here that the crew is a little bit more than the third class. Okay, so another violation of this principle is when we start looking at 3D objects, particularly when we start turning them and rotating them. So while this pie chart here on the left looks kind of cool, right? We sort of popped it apart and skewed it a little bit. It really makes it harder to compare the fractions as a part of the whole. So we want to make sure we just stick with our basic graphs here. This here's the one we actually like. Okay, this is the one we do not like. So keep it honest. Make sure your display actually shows what it says it shows. So look at this graph here and see if you can spot some problems with it. Okay, go ahead and pause the video if you haven't done so, and just look at it for a few minutes. And there are two obvious things that pop out at me. Okay, so the first obvious one is that the 50% doesn't look like 50% on this graph, right? I mean, we would think it should be a straight line, but because we've skewed it, it'll kind of turn this line a little bit sometimes. So we've got to be careful with that. Another thing is if we add these up, so if that's 50%, these here, when we add them up, should be 50%. But they're not, are they? Ends up being like 58%. So we've messed up here. So really be careful when creating these graphs. Okay, why is this graph misleading? This is done all the time in the news, this type of graph. You can pause the video here, see if you can find some things that really misrepresent the picture going on here. Okay, welcome back. I know you paused it. 1998 to 1999, we look at this jump here, right? When we jump from 80,000 to 81,000, it's the same as from 0 to 80,000. So we're not starting with 0 here. Okay, so this is, I guess, 79,000. Although hard to know because they didn't put it on there. But they didn't put a 0 on there. Also, this title here is sort of a biased title, so we want to be careful about that. Again, the scale moves from 0 to 80,000, the same amount of space. It goes from 80 to 81,000. And the actual increase is 2,000 pounds, which is actually less than 3%. And this bar here is actually 3 times the area of this bar. Okay, which really is a 300% increase, but it's not a 300% increase, it's a 3% increase. So a more accurate graph would look like this. We have an unbiased title here, and we have a scale of regular intervals here starting at 0. And we go from 0 to 10,000, and each spot is the same. Okay, this is an actual graph from CNN, so even the big boys do it. We have plus or minus 7% sampling, but what do we notice here? We start at 53. So it makes it look like the Republicans here, there's a big disparity between the Democrats and the other two parties in here, when really it's not that great. Now CNN actually removed this graph pretty quickly after they posted it. I think this was in 04 or 05, and replaced it. I'll show you that replace poll in a second, but I mean the difference in percentage points is about 8%, but the margin of error is 7%. It's likely there's even less of a difference than is even shown in the graph. So the graph makes it seem there's a huge difference between the parties, when in likelihood there may not be but 1% difference. It implies Democrats were 8 times more likely to disagree with the decision. In truth, they were only slightly more likely to agree with the decision. And the graph does not actually demonstrate that a majority of all groups interviewed agreed with the decision. So here is the updated graph. So be looking for that. That's a very common one, not starting with 0, to misrepresent the number of people. Okay, another one here. Which one of these graphs, left or right, is the more accurate graph? Hopefully you quickly see that. A is definitely the better graph. This one here, we're starting with 300. Okay, so it makes it look like this median difference is really great. It is, there is a difference, but it's not nearly as significant as shown here. It looks like it, from the graph, it looks like it's almost triple. Again, pictographs are really a no-no when trying to represent data. Here, maybe we're trying to show that this is double, I think was the caption that I saw here. But when you double the length, width, and height of a cube, it actually increases the volume, which now we're in 3D now, so we're looking sort of three-dimensionally, by a factor of 8. So maybe if we were wanting to show this was 100, and if we doubled it, this would be 200. But really, when our eyes catch this, this looks like it's actually 8 times the 100. So this may look to the eye like it should be around 800. So you always want to be leery about the pictograms. Even when they do provide pictograms, they usually will provide the numbers, so at least you can look at the numbers themselves to look at that. Another pictograph, you just got to be careful with these because our eyes again focus on the volume of these. So even this one here, if we look at 92 to 96, only 0.2 difference, 0.2 million here, and the picture looks like it's significantly greater than 1976. Okay, and this one is really terrible. It's hard to even know where to look on this one, right? I mean, for one, usually we start the lower values to the left and go up, but that's the least of its problems, right? Pause the video here and see if you can find a few problems here. All right, welcome back. So a couple of problems stand out to me. They don't even give you the percentages on all the bars. So this one here is missing the percentage. It's hard to know where to look. If I'm looking at this, do I look at this bar here to compare? Do I look at this one? Because they're not the same because of the sort of the curvature of this. What else? Here, notice the difference here. This bar here is between 50,000 and 74,999, whereas this next bar is between 40 and 49. So that's a difference of about 25,000. This is a difference of about 10,000. And then this one here, for some reason, they didn't even want to do 10,000. They went from 30,000 to 39,999. And so there's just a lot of problems with this graph. So in summary, what can make a graph misleading? The scale is too narrow, not in a big enough range. The data looks like it has a big difference, but it really doesn't. We saw several of those. If there's no scale at all, and that was another problem with that previous graph that I showed you, it didn't have a vertical scale on it. The bars aren't equal widths, like in that last graph. That last graph really had it all, didn't it? If the intervals on the graph aren't equal, but are depicted as being equal, and so we've seen some of those, and they can also be misleading if they're missing information. So you want to make sure that it has all the information there.